Let's talk about a huge headache in deep learning, the vanishing gradient problem. Let's get into it.
So, you'd think adding more layers would make a network smarter, right? But weirdly, it often just breaks them.
And this is it in action. The learning signal, the gradient, basically fades to a whisper for the early layers.
So, what's causing this signal to just die out? Turns out there are three main culprits on our list.
Okay, culprit number one, old school activation functions. These are the things that decide if a neuron even fires. See that graph on the right? The gradient is basically zero everywhere except for that one tiny little spike.
All right, culprit number two comes from basic calculus. It's the chain rule, and it's a real killer here.
Think about it. You multiply a bunch of small numbers together and the result gets tiny, fast. It vanishes. And our final culprit? It's how you first set up the network. Those initial guesses or weights are super important. And wow, look at the difference. Bad starting weights on the list just kill the signal. Good ones, it flows.
Okay, enough problems. How do we fix this thing? Enter ReLU, a simple but totally game-changing idea.
Right, remember this problem? The old functions, sigmoid and tang, just flatline. Their gradients just hit zero. But look at ReLU. For anything positive, its gradient is a constant one. So simple, yet it saves the signal. Okay, that's the theory. But what does this actually mean in practice? Well, the results are pretty dramatic. Just check out this chart. Sigmoid in red is basically gone, but ReLU in green keeps that signal strong. How much stronger? We're talking over 4 million times stronger. That is just insane. And that's what it all comes down to. One network actually learns while the other just gets completely stuck. So, ReLU isn't the only trick. We now have a whole toolkit to keep gradients flowing, allowing for crazy deep networks.
And it all boils down to this one crucial idea you've got to remember in deep learning.
This is the big question we're still asking. How do we make sure deeper is actually smarter?